On Tuesday, the last day we worked on problems like this, we were doing find all the solutions. What did we always have to put on the end when we were finding all the solutions? Plus 2 pi n, unless it was tangent, and then we would plus pi n. Today's another day where having your unit circle pulled off to the side is going to be really, really helpful because we're doing it again with finding solutions. The difference between today and Tuesday is that on Tuesday we were finding all the solutions, and today we are only going to find solutions on the interval. So they're going to tell us how far on the unit circle to look, and that means we would not add anything at the end. They're going to tell us how much of the unit circle they want us to look at by giving us an interval, and then we don't have to add plus 2 pi n or plus pi n. So far, so good? I'm going to put up our first example here in just a moment. All right. Talk to me on number 1. What do I need to do if I want to solve that? We're going to add 4 to both sides, because what's my goal? Yep, I want secant squared isolated. I want my trig function isolated. So 3 secant squared theta equals 4. And then what? Divide both sides by 3. So I have secant squared theta equals 4/3. Square root both sides. When I take a square root of both sides, what do you have to remember? It's plus or minus. So plus or minus the square root of 4/3. Can I simplify that radical at all? Yes. Remember, radical 4/3 is the same thing as radical 4 over radical 3. So I can change that numerator to be a 2. So I want to know where secant of theta is positive or negative 2 over radical 3. First of all, because I want positives and negatives, how much of the unit circle am I looking at? All of it. And we're solving this on what interval? 0 to 2 pi. 1 full rotation, and that's all. So 1 full rotation. And secant is the reciprocal of what? Cosine. Reciprocal of cosine. So where is this true? Where is the secant of theta, positive or negative, 2 over root 3? Pi over 6. Anywhere else?
7 over 6.
Yep, 5 pi over 6, 7 pi over 6. Anywhere else? 11 pi over 6. Why do I not need to do the plus 2 pi n on these?
Because you have an interval.
Because we have an interval. It said I'm supposed to solve this on the interval. I just want one rotation around the unit circle, and I'm going to list all those angles, and then I'm done. If it said all solutions, then all of those would need a plus 2 pi n on it. Number 2. I'm noticing something on number 2 that we haven't run into before. Yeah. I have 2 trig functions. They're on the same side. Is it the same trig function? No. Two different trig functions. In the past, when I've had 2 different trig functions, I could factor one of them out because it was part of both terms. Can I do something like that on this one?
Could you take the secant squared out?
How can I take a secant squared out? I like that idea. Let's talk about it.
You could, instead of secant squared, it would be secant squared plus 1.
Yes, I can do a Pythagorean substitution right here. And I'm going to replace that secant squared theta with a tangent squared theta plus 1 plus tangent theta equals 1. Now I have 2 that are the same, tangent squared and tangent, and I'm pretty sure that I can combine some like terms together. Not even there yet. Huh? Not yet.
You just subtract 1 from both sides.
There we go. That's what I'm after. I'm going to subtract 1 from both sides. What would that give me over on the right? 0. So now I have tangent squared theta plus tangent theta equals 0. So I'm going to kind of think about this as if it said x squared plus x equals 0, because I have something squared plus something just like it equals 0. What can I do with x squared plus x equals 0? I can factor what? I can factor an x out. So here I can factor a tangent out. Let's factor a tangent out to the front. So tangent of theta, what would that leave me with? Tan theta plus 1 is equal to 0. Once I get something into factored form, what do I want to do with each of those factors? Set them equal to 0. So tangent of theta equals 0. Tangent of theta plus 1 equals 0. Where is this true? It's true at 0. It's true at pi. I'm not going to include 2 pi, though. Why would I not include 2 pi? Yes, there's a parenthesis on that interval around 2 pi, so that means it doesn't include 2 pi. It goes all the way up to it, but I don't include it. But I can include the 0. All right, for tan theta plus 1, I'm going to subtract 1 from both sides. Where is tangent of theta equal to negative 1? 3 pi over 2. I thought that was sine. Where's tangent of theta negative 1? Where does tangent of theta reduce to either 1 or negative 1? Yeah. All of my over 4s are where it reduces to either 1 or negative 1 for tangent. Which ones of those give me negative 1?
7
Yes. 3 pi over 4, 7 pi over 4. How are we doing?
How do you know where 10 is equal to 0?
You look at your unit circle.
Mm-hmm.
Tangent of theta is sine over cosine.
Right.
So it's where sine is 0
Cosine is 1.
and cosine is 1. Or negative 1, as long as that numerator, as long as your sine value is 0. Do you understand when tangent of theta is negative 1 part?
Yeah.
Okay.
Sine over cosine.
Yep, sine over cosine, so you're looking for where those are the same, but one is negative and one is positive. Do you guys have any other questions on these two before we go and look at another one? All right, let's put a couple other examples up. On number 3, I have two different trig functions. I have sine and I have cosine, right? Should I look for a substitution like we did last time?
You can just divide by sine.
Divide by sine. I can only divide if I know for sure that it's not going to simplify to 0. Is there anywhere on the unit circle that sine is 0? Then I can't divide by sine because x might take on those values. So if I can't divide, what could I do to get things to the same side? I can subtract. I'm going to subtract sine of x to get a 0 over there on the right. So I'm going to subtract sine of x here, but it's not going to combine with my 2 cos x sine x. That's a mess. So I would have 2 cos x sine x minus sine x equals 0. Why is it not a like term with that 2 cos x sine x? Yes, ma'am.
The 2 cos x sine x are together, and the sine x is like separate, and to get them together you have to multiply, and you're not.
That's exactly correct. If it was just 2 sine x, then I could, but because of that cos x, you can kind of think about it like another variable. That'd be like 2xy minus y. I can't combine those together. They're not like terms. Your explanation was absolutely correct, Nani. So if I can't combine them, what can I do? I can factor out sine. So I'm going to have sine x, and what would that leave me with?
2 cosine minus 1.
Yep, 2 cosine x minus 1 equals 0. Take each factor and set it equal to 0. Sine of x equals 0. Where is this true? Yep, 0 and pi. So x equals 0. It equals pi. Over here, I need to add 1 to both sides and then divide by 2. 2 cosine x equals 1. So where is cosine of x 1/2? You said it's where? Pi over 3. Anywhere else on the entire unit circle? 5 pi over 3. I should have checked this on the last one. We'll go back and check it in just a second, but I want to talk about it here too since I'm right here. I always have to make sure if there are different trig functions in my original equation that none of my answers are outside the domain of anything that I had happen up here. Do you guys remember on Tuesday how we got a no solutions one? Because we had some things that like it worked for one, But when I took that angle and put it in the other trig function, it was undefined. It was outside the domain. What is the domain for cosine of x? What are all the possible values that we're allowed to use for x? Think about when we graphed it. Negative infinity to positive infinity. All real numbers. Cosine, I'm allowed to have any angle measurement. So do I have to worry about any of these making cosine undefined? What about for sine? Same thing. All real numbers, so I don't have to worry that any of these are going to make sine undefined. Let's go back and look at the previous example real quick because we forgot to check that one. Here I had secant and tangent. What were the angle measures that I got back? 0 and pi. Is secant defined at 0? Secant is the inverse, or sorry, not the inverse, the reciprocal of what? Cosine. What's cosine of 0 radians? 1. So if I make that the reciprocal, is that okay?
Yeah.
So it's inside the domain. What about pi? -1. So when I make that the reciprocal, it's still -1. So both of these work in secant. Do both of these work for tangent? Is tangent defined at 0 radians? Sine over cosine. Yeah. It would simplify to 0, right? But it is still defined. What about at pi? Sine over cosine? Yes. Where is it undefined? Where is tangent undefined at? Pi over 2 and 3 pi over 2. Those are the only things that are going to break my tangent function. None of these are pi over 2 or 3 pi over 2. Where is secant undefined at? It's where cosine is. Where cosine is 0, because that would be something over 0. Where is cosine 0? Pi over 2 and 3 pi over 2. Are any of these angles going to cause a problem with secant or with tangent? Nope. So all those answers are good. But you have to remember to check, because sometimes you'll find something that works when you're just looking at an isolated piece, but it doesn't work in the whole big thing. Right? Number 4. What's happening here? Tell me what you notice. We've got cotangent, we've got cosecant, and I heard we also are noticing that horrible fraction. We'll deal with the fraction part in a minute. Cotangent, cosecant. Same trig function? Nope. Can I factor the same thing out of both of them?
No.
Not really. Can I rewrite any of them? Yes. What can I rewrite? I could write cotangent as cosine over sine. Does that help me get to cosecant?
You can write it as 1 minus cosine squared minus 1.
Cosecant squared minus 1. The reason I'm not doing cosine over sine, we could do cosine squared over sine squared, but I'm keeping an eye on the other side, because if I can make them the same, then I can probably use a factoring technique. So we've got our Pythagorean identity, which is cotangent squared theta plus 1 equals cosecant squared theta. So I can replace cotangent with cosecant minus 1. Sorry, cosecant squared minus 1 is equal to 3 over 2 cosecant theta. All right, let's deal with that fraction. Does anybody like working with fractions like this?
You can multiply
We can multiply. What can we multiply by?
2 by both sides.
Yes. I can multiply everybody by 2, and we can clear that fraction out. All right, so that's going to cancel. So now I'm going to have 2 cosecant squared theta minus 2 equals 3 cosecant theta. You guys see that cosecant squared? And see the cosecant without the squared? I want you to think about this. Like 2x squared minus 2 equals 3x. Yeah, this is a quadratic equation, so I'm going to use a quadratic solving technique. When I'm solving a quadratic, I want it equal to what?
0.
Equal to 0. So how do I get this one equal to 0? Yes, subtract 3 cosecant from both sides. So that's going to cancel there. So I'm going to have 2 cosecant squared theta minus 3 cosecant theta minus 2 equals 0. So I'm still thinking about this like a factoring problem. If I'm looking at it with the x's there, I can make this. I would need 2 numbers that multiply to give me what? -4, and add to -3. What multiplies to 4 and adds to -3? -4, +1. I'm going to use factoring by grouping. If you prefer using a box and area model, feel free. So 2 cosecant squared theta minus 4 cosecant theta plus 1 cosecant theta minus 2 equals 0. I'm going to make my groups. What can I take out of the first group? Not -2. I want to take out 2 what? 2 cosecant theta. What would that leave me with? Cosecant theta minus 2. Out of this second group, what can I take out? +1. And that would leave me cosecant theta minus 2. So here's one of my factors. Cosecant theta minus 2. And this is my other factor, 2 cosecant theta plus 1. What to do with each factor? Set it equal to 0. Cosecant theta minus 2 equals 0. So cosecant theta equals what? Not over on the other one yet. 2. For the other one, yes, it is -1/2. 2 cosecant theta plus 1 equals 0. Cosecant theta equals -1/2. So, where is cosecant theta equal to +2? You said pi over 6 and 5 pi over 6. Where is cosecant theta equal to -1/2? Nowhere. So that means it's absolutely impossible for that factor, 2 cosecant theta plus 1, to ever equal 0. The other one can equal 0. Will either one of these angles cause a problem with cosecant up here? Nope. Will either one of those angles cause a problem with cotangent? Nope. So we're good. I only have two solutions here, and they're within the domain of both of these. I'm going to put up the next one. And as you guys are copying down the next problem, I have two questions that go together that I want you thinking about, okay? So go ahead and copy this down. My two questions that I want you guys to mull over is, can I make a Pythagorean substitution like we just did? And the second question is, do I want to? So I want you to keep both of those in mind while you're copying this down. Can I make a Pythagorean substitution, and do I want to? All right. Can I make a Pythagorean substitution? Do I want to? No. Why not? Yeah, I already have the same trig functions. If I do a Pythagorean substitution, I'm going to screw that up. So these are already the same. I see one of my cosines is squared. The other cosine is not squared. So this is a lot like 2x squared plus x minus 1 equals 0. What would you do with this quadratic right here? You'd add 1 to both sides? Factor it. I need two numbers that multiply to give me what? -2, but add to +1. What are the numbers that'll do that? 2 and -1. Some people still prefer the area model, the box. So I'm going to show that this time on this one instead of factoring by grouping. So 2x squared, -1. I would have 2x and a -1x. So how's this going to factor for me? This direction I can take out a 2x. What can I take out here? -1. What can I take out here? X. And here? +1 or -1? +1. So if this is the way it factors with x's, how do I want to rewrite my equation with cosines? How would that look fully factored? Yes. To cosine theta -1, cosine theta +1. It's very helpful to think of this almost like our U substitution that we learned how to do first semester. I'm going to take each one of those factors, set it equal to 0. So cosine theta is either equal to what or what? -1 or +1/2. So where is cosine +1/2? Yep, 5 pi over 3, 5 pi over 3. Where is cosine theta equal to -1? Pi. Remind me one more time. Why are we not adding a +2 pi n on these? Yes, they asked me to solve it on the interval, one trip around the unit circle. If it says all solutions, that's when I need to do the plus. If it says on the interval, I just need to make one trip. Do I need to check these? What do you guys think?
I don't think we have school tomorrow, so can I finish it?
Okay, why not?
Because they say the pedestrian is supposed to snow tomorrow, so it's gonna be slippery.
Oh, lovely. I hope you're wrong, but that's not yours. This is yours. Do I need to check these? What is the domain of cosine? All real numbers. So is any angle value going to be a problem for cosine? Nope. So I'm good there. I want to do one more problem with you guys today, and then we're going to shut it down for today, and I'll pass back your quizzes so that you can see those. Same two questions on this one as you copy it down. My two questions at the beginning of the last problem are, can I make a Pythagorean substitution, and do I want to? So copy this problem down and think about those two questions. Can I make a Pythagorean substitution? Do I want to make a Pythagorean substitution? So what do we think? Is it possible to make a Pythagorean substitution? Yes, just like on the last problem, it's possible. Do I want to? Why yes?
Because they're two different.
I have two different trig functions. There's nothing that I can factor out of a cosine squared and a sine, so I have no common factors to pull out. So I want to make a substitution. So what is my Pythagorean substitution going to be? What thing can I replace? 1 minus sine squared is going to take the place of cosine squared. So that's going to go inside parentheses. I'm going to bring everything else down. So that 2 is going to be distributed to 1 minus sine squared. So I'm going to distribute this 2. So I'm going to have 2 minus 2 sine squared theta plus 3 sine theta minus 3 equals 0. Is there anything I can combine together? 2 and negative 3. What will I get when I combine those? Negative 1. So I have negative 2 sine squared theta plus 3 sine theta minus 1 equals 0. Tell me about my leading coefficient. What is the leading coefficient? Negative 2. Do I like negative leading coefficients?
No.
Then I'm going to pull out a GCF of negative 1 so that I can have a positive leading coefficient. So 2 sine squared theta minus 3 sine theta plus 1 equals 0. This reminds me a lot of 2x squared minus 3x plus 1. How would I factor 2x squared minus 3x plus 1? I need two numbers that multiply 2. 2. And add 2. Negative 3. What are those two values? Negative 2 and 1? Negative 1. Thank you. All right, so if I used grouping again here, 2x squared minus 2x plus x plus 1 equals 0. I look at my two groups. What can I take out of the first group? 2x. And that would leave me with what? X minus 1. Oop, I wrote that as a plus and that was not supposed to be. No, I wrote this as a plus and it wasn't supposed to be. There we go. What about with that second group? I can take out what? Negative 1, yes. And that would leave me with x minus 1. So my two factors, here's one of them. 2x minus 1. And the other factor would be what? Just x minus 1. Mm-hmm.
Is it okay if you did negative 2x plus 1 instead of 2x?
Should be, yeah. I just don't normally like to deal personally with negative leading coefficients. As long as you end up with the same final answer as me, your method is probably fine. So talk to me about how this guy over here is going to factor then.
2 sine
And sine theta minus 1 equals 0. I'm going to take each of my factors, set them equal to 0. So 2 sine theta minus 1 equals 0, which means sine theta would be equal to what? 1/2. Sine theta minus 1 equals 0. So sine theta is equal to 1. Where is theta equal to 1/2? Pi over 6 and 5 pi over 6. Where is sine theta equal to negative 1? Or sorry, positive 1, you're right. Pi over 2. I still had negative 1 on my brain. I put 3, you're right. Good grief. I was stuck on those 3s. Do I need to check these? No, why not? Cosine is all real numbers, sine is all real numbers. So I don't have to worry about falling outside the domain. All right, we're going to shut it down there for today. I'm going to pass back your quizzes so you guys can see how you did. You cannot leave the room with these quizzes, but you are welcome to talk to me or anybody else.